Let's examine these two pictures here to see the difference between lifting something and carrying something upward. And the important thing for this video is how that's going to affect the amount of work done here in a lift and here in a carry upward. If you look at the lift, would you agree that just one object moves upward? The block, the 20 kilogram block was here, it moved up to here. It definitely moved up. Now the body is still on the ground, isn't it? I mean, it straightened out some, but it really didn't move up, did it? So we see here with the lift, just that one object moves up. That's it. What do you think about carrying something upward? Peek back here for a second. What do you think? Look at that. Think to yourself, how many objects are moving upward in this picture here? And I hope what you concluded is that two objects are moving up. Two of them. Obviously the block still goes up, but in this situation, this object called the body, he also goes up, doesn't he? So we have this 20 kilogram box or block moving upward, and the body goes up. Now one way of looking at this is down here. The stickman's muscles must move his body up as well as the block. I mean, it takes effort and work to move that body up, doesn't it? Sure it does. And it did not move up over here in the lift. It stayed down here. So the fact that we have two objects here moving up rather than one here is going to affect the amount of work that is done for sure. All right, let's look at lifting. Remember, work is a force times distance. And also remember, it's very important in lifting something that the force exerted is equal to the weight of the object, isn't it? So this guy here has a weight. Well, the force we're going to use is equal to weight, which as you recall is mass times gravity. This guy's 20 kilograms times g is always 10. So the force of gravity or weight down here is 20, and that's the force we're going to exert to lift it. So our force is 200 newtons. Distance here is 1.5. We're looking for work, which is that formula there. Plug it in, and we've done 300 joules of work to lift that block 1.5 meters. Here's your code. Better write it down. All right. Now let's move on to carrying something upward. Again, work is a force times distance. But here the thing is, you've got to move two objects. So you have the force to move the block. We saw that before, 200 newtons. It's the weight of the block. But here, the weight of the body is 70. That's his mass times 10, 700. So the total force upward to move the block and the body is 900 newtons. It's no longer 200. You've also got to move that body up, and that takes 700 newtons. Total 900. Then the rest is easy. Our force now is 900. I'm having the same distance over here, 1.5. Work, fill it in, and now you get work of 1,350 joules. Much more. Why? You're also lifting the body. Not just one object, but two. So two things to remember about lifting and carrying. For both, the force is weight. This thing here is 20 kilograms. Its weight is 200 newtons. That's the force to lift it, is the weight. That's true in both lift and carry upward. But when you're carrying something upward, you've got to move the object and the body itself. It takes muscle action, for instance, for this guy, and force to move the body upward. So when an object is carried up, the object doing the carrying is moved too, and that takes work. You've got to do both, include both forces in your work calculation. Bye.